Okay, good evening. This is Professor David J. De Los Reyes. It's January 20, 2023. My lesson for tonight will be Advanced Mathematics, and this is now lesson number 6. My topic for tonight will be Advanced Mathematics, lesson number 6. I will try to give you an example for tonight. It will be a second order non-homogeneous differential equation. Okay, example number 5. Okay, let's try to proceed. Okay, I will check my camera. This is now lesson number 5. The given non-homogeneous second order differential equation is y double prime minus 4y is equal to 3e to the 2x. I think the last time around I have given one example in which the right hand side is an exponential function, but the sign of the thing on the left hand side is actually plus. But for tonight, what is given is y double prime minus 4y is equal to 3e to the 2x. What I will be presenting tonight will be another variation of a solution. Okay, the right hand side is exponential, but the sign on the left hand side is negative. Okay, the problem is asking for the general solution. Okay, let's try to bring out the solution. For the complementary solution, as always, we start with y sub c equal to k e to the mx. Y prime of complementary km e to the mx. Y double prime of complementary equal to km square e to the mx. Substituting km square e to the mx minus 4k e to the mx equal to 0. We are following this. Okay. There is a common factor k e to the mx, so this will disappear. This will disappear. What remains on the first one will be an m square. Second portion on the left, this will disappear. This will disappear. Okay. This is multiplied by 1. Okay. So what remains on the left, on the second part, will be negative 4. And this should be equal to 0. If we are solving for the complementary solution, we will always equate the right hand side to 0. So this is equal to 0. Okay? What comes out now will be a characteristic equation that is an m square minus 4 equal to 0. Solving for m, luckily, we could solve it, what you call this, the positive way. That is an m square equal to positive 4, that is actually transposition. M now will be, since this is plus, okay, the resulting values of m will be a plus and minus. So the m now will be a plus or minus the square root of 4. So m1 now will be plus 2, and m2 is equal to negative 2. So it falls under case number 1. Okay, under the solution of the second order differential equation. Case number 1. Y complementary now will be k1 e to the 2x plus k2 e raised to minus 2x. That's the complementary solution. It falls under case number 1. They are both real and unequal. Okay, let's try to bring out the particular solution. For the particular solution, okay, we will assume that the y sub p, meaning p here refers to particular, should be an unknown constant a times x e to the 2x. The last time around, our particular solution, okay, even with the right hand side an exponential function, it is simply an a times e to the 2x. If we try that one, okay, what will come out will be an unrealistic thing. We could not formulate the equations and how to compute for the unknown coefficients. Okay, I am telling you now. I have tried that one. So for the solution of this, an exponential function, and this is negative, the proper particular solution should be an unknown constant a times x times e to the 2x. This e to the 2x emanates from this. Okay? So what is only unknown to compute for the particular solution is the constant or the coefficient a. But I am telling you that since this is negative, there should be an x over here. It's a trial and error. I have gone to the other solution and I tried it. It will become unrealistic. We could not formulate our equations. So as a second trial, this is actually a second trial. The particular solution should be an a non-constant a, times x times e to the 2x. Okay, that is our as an second assumed particular solution. But for tonight, it will be the sure solution because I've done the first one already and it was not correct. Okay, taking y prime. First derivative of particular will be equal to x times e to the 2x, a product of two functions, right? Times a constant, so it will be that constant times the derivative of these two functions here. First times the derivative of the second plus the second times the derivative of the first. As simple as that one. Okay, the differential or the derivative of a product of two functions. So it will be an a, open bracket, x times 2e to the 2x plus e to the 2x times 1. First one times the derivative of the second plus the second one times the derivative of the first. Simplifying, what will come out will be a 2ex e to the 2x plus ae to the 2x. That's the first derivative of the particular solution. Taking again the second derivative. The second derivative is the derivative of the first derivative. Y double prime of the particular solution should be equal to, we'll take again the derivative of the right hand side. It will be a little bit long because it contains two terms. And the first one is the product of two functions. And the second one is just an exponential function. So for the first one, we'll try to use the so-called derivative of the product. So it should be 2a times the first function, derivative of the second, plus the second times the derivative of the first, close bracket, equal to the derivative of this one. A is constant, this is an exponential function, it should be a times e to the 2x times 2. So what will come out will just be simply 2a times e raised to 2x. And if we try to simplify this one, there are common terms. It will be a 4ex e to the 2x plus 4a times e raised to 2x. There is an x over here. This is just a pure constant times the exponential function e to the 2x. That's the value of y double prime. Substituting. I check my camera. Substituting. We will take the second derivative, we'll substitute it here. So what will come out will be this one here. Right? Minus 4 times the assumed value of particular, that is, this will be minus 4ex. We are following this. And this should be equal to 3e to the 2x. There is a common term. Oh, I think this one cancels. Okay? Luckily, 4ex e to the 2x, that's positive. This is negative 4ex e to the 2x. This minus is plus, they cancel out. So what remains on the equation will just be simply 4a e to the 2x equal to 3e to the 2x. Okay? Equating coefficient of like terms. On the first solution, on the equating coefficient of like terms, we could not formulate an equation that will solve for the unknowns. It's unrealistic. So the assumed solution on the first one, I have not shown it to you, but I assumed that the solution was the same as the last time around. It was not correct, okay? But for this one, this is our assumed particular solution. We put an x over here. So equating coefficient of like terms. e to the 2x. All the terms with e to the 2x for both the left and right, we equate the coefficients. So for e to the 2x, the coefficient on the left hand side is 4a. Right hand side, it will be 3. Okay? So a now will be 3/4. Okay? The particular solution now will be 3/4, will follow this. X e to the 2x. If you assume that the solution was the same as from the previous example, okay, it will not come out like this. You cannot formulate an equation that will solve for the coefficients. That's why as a second solution, the one I'm showing you now, the particular solution, the assumed particular solution, which is correct, will be an a times x e to the 2x. And after the computation, we have formulated an equation that will compute for a. And a is 3/4, therefore the particular solution will be 3/4 x e to the 2x. So the general solution will not just be simply the sum of the complementary plus the particular. This is the complementary solution, q1 e to the 2x, q2 e to the minus 2x, plus 3/4 x e to the 2x. This is our final answer. Okay? And to check the validity of our answer, we will take the first derivative. We got the final answer, right? We will take the first derivative. If we try to take the first derivative, this will be the first derivative. Okay? Y prime will be the derivative of this. This should be q1 e to the 2x times 2. So this should be 2 q1 e to the 2x. The derivative of this will be q2 times e to the minus 2x times 2, negative 2. So this will now be negative 2q2 e to the minus 2x. And the derivative of this, constant times a product of two functions, algebraic, exponential. So we bring out 3/4. Okay. First one times the derivative of the second plus the second times the derivative of the first, close bracket. Okay. That's the first derivative. And if we try to take again the derivative of the first derivative, what will come out will be, take again the derivative of this one. 2q1 times 2 will be 4q1 e to the 2x is plus, because the sign of the exponent is plus. For the second one, the derivative of this, it should be negative 2q2 times e to the minus 2x times minus 2. Minus 2 times minus 2, this will become plus 4q2 e to the minus 2x plus. The derivative of this, it's the same. Okay, 3/4. Okay. We take the derivative of this as a product again. So it will be first, that's the derivative of the second. This will now become 4 because this is 2 times 2, this will be 4 e to the 2x. Okay, plus the second part, 2 e to the 2x, times the derivative of x, which is 1. That's the derivative of this. Plus the derivative of this. It will be e to the 2x times the derivative of the exponent, which is 2. Or it will just be simply 2 e to the 2x. Or y double prime, if we try to simplify, y double prime, the second derivative. 4q1 e to the 2x plus 4q2 e to the minus 2x. If we try to simplify this one, what will come out will be 3x e to the 2x plus 3e to the 2x. Okay? Because 2 plus 2 will be 4 times 3/4. Okay? What will come out will be 3. That's the second derivative. That's the simplification of the second differentiation. And if we try to take the value of y, we multiply it by 4. We multiply the general solution, the total solution by 4, negative 4. 4 or y times negative 4 will be negative 4y. K1 e to the 2x times negative 4 will be negative 4. This will be negative 4. We multiply this by negative 4. Okay? This will be negative 4 K2 e to the minus 2x. And if we multiply this by negative 4, 3/4 times 4, this will cancel out, but it will be negative. So this is negative 3x e to the 2x. That's the value of y after the multiplication of negative 4 to all the terms. this part here, what will come out will be negative 3x e to the 2x. Okay? And to check the validity of our answer, we'll add the operations of addition, right? Y prime plus open quantity negative 4y, it will be y prime minus 4y equal to, the operation is addition. This term here is similar to this, it will cancel out. This negative, this plus. K1 e to the 2x, K1 e to the 2x, they are similar. This is plus 4, this minus 4, they cancel out. Second term, e to the minus 2x, e to the minus 2x, this is plus, this minus. They will cancel out. Okay? They are similar terms. This is an x e to the 2x, this is an x e to the 2x, the coefficient of this is plus 3. Okay? Plus, open quantity negative 3, the operation is addition, right? So plus 3 minus 3, actually this cancels out. Okay, so what remains will just be simply, the operation is subtraction. This is actually plus 0 over here. 3e to the 2x plus 0 will be 3e to the 2x. And this one here is similar to this. Okay, 3e to the 2x. So after taking the first derivative, we subtract or we add the value of y after multiplying it by negative 4, okay? What will come out on the right hand side is actually 3e to the 2x. Also, the significance of this, the assumed particular solution was correct. That's the significance. That's the only way I can shoot to you guys if our answer is correct. That's why I told you to check the validity, take the first derivative, take the second derivative, then add the value of the negative value of the total solution, negative 4y, by multiplying all this by negative 4. So this will become negative 4y, negative 4k1, negative 4k2, negative 3. Okay? Then try to take this out. The operation is addition. Right? Fundamental operation. Y prime plus open quantity negative 4y will be y prime minus 4y. These are similar terms, they cancel out. Similar term, they cancel out. Similar term, they cancel out. 3e to the 2x plus 0 is just simply 3e to the 2x. And that is equivalent to the given right hand side. So that's how we check the validity of our answer. Okay guys, that's it. So for those guys who are taking advanced mathematics, this is for you. Okay, if you want to like my video, please click like. And if you want to subscribe to my channel, please click subscribe. My channel is at youtube.com/@ProfDavidJ.Reyes. And if you want to share it, please click share. Good evening, Los Angeles.